Hold on one second. Let me just say something. It's a tangent to a straight line which is on a curved surface.
Yes, this is basic geometry. Your flat Earth geometry. Flat Earth geometry. This is basic geometry.
It is.
I called you a flat earther.
My name's Ramsey.
Insisting that your flat Earth geometry will work.
I'm familiar with the bubble, Morty. I also dabble in precision, and if you think you can even approach it with your sad naked caveman eyeball in a bubble of air, you're the reason this species is a failure, and it makes me angry.
Did he say a five-sided square question mark?
You're a universal horizontal waterer.
You're drunk.
I called you a flat earther.
You want to experience true level? Do you? Yes. You want to experience true level?
That auto level is establishing a horizontal. That's just the way it is.
Because I've done the test with an auto level, which gives you a horizontal.
Yeah, it's gonna look super flat.
All right, come on. Wow, it's so.
Three coplanar points.
Oh Christ! Yeah, true level, bitch.
I called you a flat earther.
If you're into math, there's a certain shape where you could make a five-sided square.
Are you suggesting that horizontal can't curve?
Oh, everything's crooked. Reality is poison. I want to go back. I hate this.
What's his deal?
Morty. Go to school, Summer. I'll go in Morty's memory and do a little.
Randy, come on, that's a globe. He eventually just gave up and said, yeah, I agree, it's a globe.
Geodesic is a continuous string of infinitely small, straight lines.
Yeah, true level, bitch.
It's pretty flat and level now.
Randy, come on, that's a globe.
Yeah, true level, bitch.
Randy, come on, that's a globe.
Lance to the cosmic slaughter! Well, you seem to be in charge of what I get to remember. Why? Good question.
Randy, come on, that's a globe.
I'll go in Morty's memory and do a little. Wow, it's so. Oh my god! Oh Christ! Yeah, true level, bitch.
If you're into math, there's a certain shape where you could make a five-sided square.
Randy, come on, that's a globe.
Yeah, true level, bitch. Wow, it's so. Oh my god! Oh Christ! Yeah, true level, bitch.
I called you a flat earther.
True level, bitch.
I called you a flat earther.
True level, bitch.
I called you a flat earther.
Yeah, true level, bitch.
Person to think.
When you get to the end of this test and you have a result and you say level is horizontal and everyone says big whoop, that doesn't prove anything about the shape of the earth, will you then say yes it does?
No.
No. Okay, I'm going to bed. Right.
Okay, so you.
I'm going to bed.
That level is horizontal is good for you then, right?
I agree. I agree. Level's horizontal.
Sweet.
Right,
true level, bitch.
Perfect.
Wow.
Nice, mate. I came
Nice.
in just for that. You flipped it, man.
Yeah, true level, bitch.
Right. Presume, right, that everyone in the room hasn't got a clue. Please describe a curve. It's very simple. Go.
Yep. So that's basically what I said before, that you could say that it's just a line, any line. It's a bit more complex when you try to define it rigorously, but you can think of it just as any line. Can also be a straight line. I would say that a straight line is a special kind of a curve.
Yeah.
Basically a curve with some additional properties.
So you can have a
Like-
curve being a straight line and a straight line being a curve. And you don't see that there's a problem with the law of non-contradiction there at all, do you?
It's not a law of it's not a contradiction. There is not a problem with law of non-contradiction because you're still stuck with definitions that basically, well, you're still trying to stick your understanding of the word curve to what I'm saying that I define as the word curve. Well, the other way around. What I define the word curve to mean.
Think about looking through an auto level, right?
As for
And then you- and then
tangent
you-
having only one point in common, okay?
And then you tilt the auto level down so the crosshairs are touching the horizon. That's a tangent. It's a horizontal plane intersecting with the horizon. That's your tangent.
Problem with like how Bballs explaining it is, I've got a tape measure, and if I stretch that out, that tape measure is straight in one way, but if I let it curve the least amount, my measurement's off. So I need that thing as straight as possible in the strictest sense. So when you say something is straight but curved, it's just a problem for me.
Well, look at the picture I just posted in the chat. That's a straight road, right? But we're going over several hills.
That seems
Is
like a
that-
colloquial sense of a term straight.
Am I still not driving straight?
Well, I mean, it's still got curves in the road.
No, it doesn't have curves in the road.
Hold on 1 second. Let me just say
have-
something. It's a tangent to a straight line which is on a curved surface.
It has hills in it.
I'm driving straight. I'm not turning left or right.
And so again, if you look three-dimensionally, then of course there are curves in like the vertical direction, right? But if you look at the geometry of the surface itself, if you just
Hold on 1 second. Let me
And
just say
you have-
something. It's a tangent to a straight line which is on a curved surface.
if you just restrict yourself to the two dimensions of the surface, to the left, right, and forwards, backwards, in this sense, it is straight, right? It doesn't turn left or right, and that's the point. Actually, if the hills have different shapes, then actually this road might not even turn out to be straight. It depends on the geometry of the surface, but yeah, I think that's the point here.
So can I answer your question, guy?
Hold on 1 second. Let me
And
just say
you have-
something. It's a tangent to a straight line which is on a curved surface.
And just looking at B-Ball's picture. The lines on the outside, are those lines curved or straight?
Well, of course, if you're in the center and looking out, they look curved. Yes. So what's
It
the
basically
point? But
depends.
I'm still not driving to the left or the right, am I?
You still going up and down, right?
But I'm not turning my wheel, am I?
Right. No, you're not. But you are going up and down, right?
Yeah, but yeah, I'm going up and down, but I'm still not deviating to the left or the right, so I'm still driving straight. No one ever says, "Hey, go down the road, and make sure you turn your wheel to the left because you're going up a hill."
You two-dimensional thinking there, B-Ball. Can you not see the third dimension?
Yeah, but
the point.
we're not concerned with the third dimension though. We're just
Yes,
concerned
we
with
are.
going straight.
We're concerned about
with going
straight in reality.
We're concerned with going
some
straight
contexts,
to the surface.
Yeah, what you're missing, Bev, is that geometry is a tool, and in some contexts it's simply useful to disregard the third dimension and only be concerned with the two dimensions.
No,
and in such a context,
it's never ussul to confuse people
Oh,
about
yeah,
what
it's
straight
sometimes very useful.
is within geometry. Definitely not.
One other question to science it out, and I'll go back on mute. So, would you use a straight ruler or a bent ruler to do, whatever you need to do, measure something?
Kind of depends on what do I want to measure. If I want to measure a circumference of a ball, then a straight ruler doesn't really make much sense, does it? But I wouldn't use a bent ruler either. I would use something like a tape measure, and then curve it around the ball.
But is that straight or is it a curve?
depends in what context we talking. If we're talking in the context of the geometry of the three-dimensional space in which the ball is embedded, then of course it's curved. But then, if I'm starting to consider the geometry of the sphere itself, it might be useful to call that straight. But it's the point. It might be useful to call it straight, to define the word straight in this context slightly differently. Context is important.
You know, like
Time for
when
me
you're
to go on
trying
mute.
to
I'm good. Y'all good.
when you're trying to measure
Yes,
someone's body fat, and you use one of those measures around someone's belly, you got to make sure that little tape measure is straight around their belly. It
You
can't
don't
curve.
measure body fat like that. That's a false equivalence anyway.
Yes, I've done it. I've done it hundreds of times actually.
This is why
I know
people didn't want to get pinned down on the law of non-contradiction, because you can just contradict yourself if you don't worry about that.
And he's talking about the BMI chart to see what your body fat content is. Right. So if you ever did it for real, you know where you're supposed to measure. It's not around your waist.
Yes, I know. I know exactly where to measure it.
Is it around your waist?
No, it's not. It's around the widest part of your abdomen.
Wrong.
Yes, I'm actually right about that. And it's around the navel, around the widest part of your abdomen. And for females, it's 3 different positions, isn't it?
No.
Yes,
it goes for the same. It goes for the same for everybody. You wouldn't measure that.
Are we talking about military standards or what?
Military standards. Are you in the military?
Yes, I am.
You still active in the military?
Yes, I am.
That's weird. But I'm gonna let y'all have it.
So a straight line is sometimes a straight line, but when you want it to curve, it curves. Correct?
Yes, it's called context. I think he's been talking about it for a while.
It sounds like changing the law of non-contradiction to myself.
Nobody cares about your law.
Absolutely, Bev. Absolutely.
Not
like
quite.
One thing being two things.
You guys are so one-dimensional. It's ridiculous.
Well, of course you wouldn't want to talk about the law of non-contradiction just so you can contradict yourself.
Who cares about the law of non-contradiction? Who cares about that?
That's the basis to all conversations, Ball. It should be.
Straight lines on a surface of a sphere. You can have straight lines on a surface of a sphere. Like what's
okay? So if I'm talking apples, then you can respond to me in oranges.
Why do you guys fight against that so much? Yes, you can have a straight line on a sphere. What's wrong with that?
So an apple could be an orange. An apple could be an orange.
What does that even have to do with the conversation, Montreal?
Because you're making a straight line a curved line. I want to make that absolute.
You can have a straight line on a sphere. Why is that such a bad thing?
I would phrase it slightly differently. You can have a class of lines on a sphere
that's definitely semantics, isn't it? Where you're just phrasing something differently, so you can get away with saying a straight line is a curved line.
Important. No, I'm not saying a straight line is a curved line. I'm only saying that sometimes you might want to call different things straight lines than in other contexts.
Well, it's pretty clear what a straight line is, right?
It's only that. Well, apparently it's not.
Well, it is to us, to those people that know what a straight line is. But you and Bball seem to want to just call curved lines straight lines if you want to.
Yeah, because see, the point of mathematics is basically exploring what common properties imply what common, basically, I don't know how to even say it. But basically mathematics is about abstracting away irrelevant details. So it turns out that straight lines, as you know them, and great circles on a sphere have enough properties in common that it's useful to use a single word to describe both of them
so
in the same way.
Would that be why you can't have a tangent, then?
What do you mean?
Well, you obviously can't have a tangent to a straight line, can you? I mean, that would fucking be ridiculous, wouldn't it?
You can. It's a straight line.
What you can have?
That straight line is tangent to
can't.
itself.
No, you can't have a tangent to a straight line. That
Who says?
Depends
Who's
on-
trying to make
again.
it? Who's trying to make a tangent to a straight line?
you
Bev?
you
What are you
guys.
talking about?
He just said he is. Do you know what a tangent is, first of all?
Yes, I know. Yes, I know what a tangent is.
Go ahead.
Is a tangent a straight line?
Yes, tangent is a straight line to a sphere.
Okay, so if you've got a straight line,
Which
then-
touches the sphere at one point.
yeah, but
What about your other
what part
straight
of the
line?
sphere is it touching? A curved line, or
Mm-hmm.
oh right, so you do have curved lines on a sphere then.
A straight line on a sphere, yes.
No,
So you can't
that's
have
a tangent.
to a straight line.
Yeah, that's good. Yeah.
Think about it, B-Ball. Think about it real hard.
And there is a useful definition of a tangent, where basically a tangent to something, to a figure or to
Curved
a surface.
Yeah.
That-
Touches that curved surface at
any
one
surface.
point and 1 point only.
Okay, any surface actually. A tangent to a surface at point A would be defined the way this way basically. You take the point A, you take another point B on the surface, you put a line through the points A and B, and then basically a tangent will be the line through points A and B when B tends to the point A. Basically, you take points closer and closer to A, and the line through A and B is becomes closer and closer to the
And
tangent.
what is B? What is B?
Well, that's,
Any
that's
point at
2
all.
points, really. You can't. A tangent is only touches at 1 point, right? And 1 point only. Or have you got a new definition for tangent now?
Okay, let me put it this way.
Can I just check that you're trying to justify now having a tangent to a straight line, aren't you?
Of course, you can have a tangent to a straight line, and it is the line itself. But okay, let me put it this way.
Hold on 1 second. Let me just say
have-
something. It's a tangent to a straight line, which is on a curved surface.
Oh, are you having a tangent to a straight line as well, B-Ball?
It's on a curved surface.
Yes. Why is it so hard for you guys to understand?
If only you realize what you just said, man.
Tangent to a straight line confirmed by
straight line,
B-Ball,
which is
right?
on a curved surface. We can have a straight line on a curved surface.
And you can
So we have
you
three
can't have a
objects now.
tangent
We
to
have a tangent,
You
we
can't
have
have
a
a
curved
tangent to a
surface.
straight line, can you, B-Ball?
I know it's really difficult for you guys to understand. You guys have been trying to figure this out for how long? 2-3 years now?
Give me a picture. Make me understand.
Reject all
B-Ball.
of physics
B-Ball.
and all of geometry. You guys are trying to make
Picture.
your own geometry.
So you got a straight
Get it.
line on a curved surface that you call a straight line, but then you got a tangent to it, which you also call a
Yes,
straight
you can
line.
have-
That's a tangent
you
to a
can
straight line.
That's three
You got your
objects right
definitions
there.
mixed up.
Yeah, not to mention
Okay.
3 objects.
Think about looking through an auto level, right?
As for
then you- and then
tangent
you-
having only one point in common, okay?
And then you tilt the auto level down so the crosshairs are touching the horizon. That's a tangent. It's a horizontal plane intersecting with the horizon. That's your tangent.
Crosshairs aren't touching the horizon; they're just within the objects.
We're kind of
You'd have to angle them
going.
down in order so the crosshairs will be touching the horizon.
we're kind of going off on a tangent actually right now. But
Right.
yeah.
Yeah.
But what I was meaning to say, okay, so you guys are saying that the tangent can only have 1 point in common with the curve or surface it is tangent to, right?
Yeah. That's a tangent.
Okay. You know what a sinusoid is, right?
It's called
a curve.
it's called the tangent point, right?
Okay. Just a moment.
Yep.
Is a sinusoid a good curve for you?
Go on. Draw it for us, please.
Yeah, you know. Basically, if you just take a look at the picture that you posted actually a while ago, this level but not flat, it's basically a sinusoid, right?
That one, are you going along with that? Do you like that for a level? That's Zanuck, that. A wavy surface, right?
Okay, yeah, but I don't care about what. I don't care. I only want to.
Just for anybody else listening, you're talking about an undulating, wavy surface.
Yeah, you can call it that. I'm actually more interested in it as a curve, as a single curve, but it can also be a surface. I don't really care.
Well, it's not a single curve because it curves up and down, right?
Kind of like a hump.
Okay, I think we have another terminology disagreement here because to me the line, the wavy line, is a single curve.
Well, yeah, I'd say one of them's a negative curve and one of them's a positive curve.
Yeah, so we're using the word curve in different meanings because
concave,
to me curve is basically equivalent to a line.
Yeah,
concave, it's because they think the surface of the Earth is a straight line. That's why.
But it doesn't. But it doesn't matter. Okay, let's say that's a surface. Okay, can you have a tangent to this surface?
Yeah.
Okay, and how many points will that have in common with this surface?
Each of the curves that it touches, if they're all uniformly. Wave height, what do you call them? Frequency, or what would you call that? If they're all the same anyway, all the same height, yeah, elevation, what would you call it? If you were to have a straight line, then they would all be the same height. Then every one of those upward curves would touch it. Yeah.
For example, yeah.
Yeah. But those
upward
curves that those circles would relate to, the tangents that those circles would relate to, are joined by an opposite curve, aren't they? In order that they can join up to each other.
To me, that's still a single shape, and it's a single shape which have multiple points in common with the tangent to it.
There.
Yeah, so that's a bit of a weird terminology that you're using there.
No, I think that's you trying to play with semantics, but... So we understand that it only touches that curve at one point, right? It can't touch another point of the same circle, can it?
So, hey, Bev, am I creating a tangent to a straight line in this picture?
I don't know. Where's your circle or your curve?
If I were to tilt the auto level down so the crosshairs are touching the water, would that be a tangent? And would that horizontal plane be a tangent to a straight line? Do you guys think the water is a straight line?
I was looking at that. What's up with your vertical? Is that something in the picture or my TV or something? Or does that vertical look like it's got a slant on it?
It's probably just the way I cropped the image.
Well, but no, you can't crop that to make that vertical line.
No, but if you put a phone, put a phone to the lens slightly off center, then we will get an effect like that.
Well, I don't know. It's just the lines, right? The lines are definitely showing it up as being a slanted.
Well, is the horizontal line is it parallel to the surface of the water?
All horizontals are parallel.
You see
to the
that
plane
horizontal
of the horizon.
line going? Okay, do you see that horizontal line?
Where would you say the plane of the horizon would be in there?
Is it parallel to the water?
I don't know.
Well, I mean, you can look at it and see.
Well, yeah, look, it looks like it could be. Yeah. Have you measured it? What did you measure it at?
I didn't measure it at all.
Oh, okay.
Looks like it though.
Okay, brilliant.
But do you see what
looks great?
Am I creating a tangent?
You do realize that those crosshairs are like within an inch of your eye, right?
Yeah, but that horizontal extends forever, pretty much.
Which horizontal?
The crosshair, the horizontal line in the where the crosshairs are.
Mm-hmm. Straight line.
Yes, that's straight line. Where the crosshairs meet, that little plus sign, that extends out for ever,
No,
right?
it's in your eye line, right? It's like
Yeah,
I
yeah,
say, it's inches
it's
away
right
from
there
your
in
eye.
the tool.
Yeah.
Yeah, it's in the tool, yeah, but it extends out.
No, it doesn't. It's within the tool.
So if I
You
wanted
just
to
use
build a
that as a
wall,
frame of reference when you're
yeah,
measuring.
yeah, exactly. So if I wanted to build a wall that was horizontal to those crosshairs, I could do that, right? And I could
No, I
extend that
wouldn't.
wall
You
out
wouldn't
forever.
use it for building walls straight.
But I could though, right? I could use it to build a wall.
I doubt it.
Pretty level, right? Don't you think?
I mean, like for strange things to do. I mean, like if you're thinking of doing a GoFundMe or whatever, then yeah, I mean, I'd go for it. I don't think it'd be useful. I mean, how good of a bricky have you done? Have you ever done any brickying?
Well, I mean, isn't that kind of like what the Force the Line guys were trying to do?
I don't know.
Yeah, I think that's what they were trying to do.
What? Build a
wall or something
with
that was
with an auto level.
Very
using it
with whatever the hell they were trying to use.
He definitely wasn't. I had a word with Dell. He definitely wasn't using the horizontal. He got upset when I said he should use a water level, but I mean, so yeah, no, I don't know. He definitely wasn't using an auto level.
Yeah, but they were trying to use something.
I don't know. They were doing brickying, like you say, building a wall. Are you?
I'm sure they were going to.
Is that your next one? Your next project?
No, I'm sure they were going to use something a hell of a lot more accurate because it costs so much
for building walls.
Yeah.
No, he just used spot on. I mean, he's not. I don't think he's here, is he? No, it's a shame he's not here. Yeah, he'd show you about brickying. He doesn't use auto levels for that. He would probably for marking the corner points and stuff, but for building the wall, he'd just use his bubble level.
Yeah, but whatever they were trying to do was going to be a hell of a lot more expensive than they could afford.
Who?
All the people that were involved in the Force the Line thing fell through, and the guy ran off with the money.
What was that they were doing? I don't know. What was it that they were meant to be doing?
They were trying to build some kind of wall, or I don't know what the hell they were doing, and then the guy ran off with the money.
I said to Dell, I said you do it for a lot cheaper, £100, 400 meters. Get yourself a water level. He wasn't keen.
That makes sense, man. Good on you, Bev.
Branch, my man.
How are you with tangents to straight lines, Branch? Are you going to have that?
Well, I was a little bit. I was spending a lot of time figuring out whether or not horizontal was level, or whether level was horizontal, and after a long time of debating within my mind, within the situation, I figured out that
both the same, aren't they? Same thing.
Yeah, what really matters is, how much vagina you get before you die.
Right. You're here for the ladies, then?
Well, I mean, if you really consider, we as the animals that we are, right? Just like every other type of animal.
There is ladies in here, Branch. So
reproduction should
maybe
be our goal.
This guy is dumber than I am.
Yeah. Well, I mean, how late is it, Branch?
That's not the point.
I know, but I mean, when you start like this, Branch, I mean, this normally goes downhill pretty quickly.
I mirror people, Bev. So it's not that the conversation went this way because I'm drunk, right? The conversation went this way.
You have had a drink.
Because I mirrored the conversation I was having with you. If we were to have a very fucking intellectual conversation, it wouldn't have gone this way. You feel me, blood?
Right. Who did you come to save? Was it
I mean, what I came to say was like vaginas and anuses.
Yeah.
That was about it.
Yeah. Have we not got any mods here, or is this the usual?
No, bro, I don't think I need to be moderated. You can continue talking however the hell you was talking, and I'll shut up.
Well, I think he's gone. Did he send you a message to come save me, Branch? I'm guessing. Because he's gone.
Well, he was going on about the straight line, and I asked him if I built a retaining wall for him and followed the contours of the land. And he specified he wanted a straight wall, and I was like, "Oh no, just look at it from this direction. It's straight. Don't look at it from the front."
Yeah.
And then he said, "No, that would be level and horizontal." I was like, "Oh, yeah, you're right."
Oh, it's a shame, Branch.
Well, it's not that. Like,
Did
what
you,
I'm thinking
did you
about...
not like it? Us having a chat with?
No,
Bballs?
it's totally fucking fine.
Was he saying some stupid shit?
What I'm wondering though is this, yeah? Do you think this room has the potential to have a 24/7 YouTube presence?
I think the room underneath it's titled 24/7 Hangout might be a better room. You want to go in there?
Well, when I say room, I just mean the whole fucking server.
Ranty.
The whole server.
Wow. Is that big an attraction? I don't know. What do you think?
I think
maybe if you hang about a bit more, you might be able to entice the ladies in. You know.
Well,
Did you come in just to derail the conversation there, Branch?
Of course he did.
Hannah, come on, Hannah. Look, if I read or derail the conversation, then I wouldn't be so very fucking
drunk.
You got muted in Gems, you got muted in Brandon, so you decided to come over here.
Hannah, you know what's actually happening in my mind right now? I'm thinking that why is Hannah the only fucking woman around right now?
Branch.
I know it sounds fucking weird, right? But like, okay, I don't necessarily just think about like what the hell's happening right now, but I'm thinking like Hannah's literally the only fucking woman that's around in this, I guess, conversation.
Is this why you're here, Branch? Just because there's only a fair few places that you can go
Get
to?
away from crazy people, and then you show up.
Yeah.
And I don't think that's what's up. I think that what happens with you is this.
Is there any mods in here? Because I mean, this is just going to get
And
worse.
Naps is in here too, and she's a woman, so you're wrong about that.
Well,
she's deafened.
Hannah, tell me I'm wrong when I say that. You really just want good conversation with people that you can feel together with. It's not about flat Earth for you. It's just
It's not about flat Earth for loads of us.
Loads
of us just want to talk to each other, try and make sense out of everything that's going on.
I'm pretty sure that for Hannah, like flat Earth has never been the crust of this entire conversation, and like, you know, the same way I cringe at people getting mad at flat earthers, I think Hannah does a little bit too, because I don't like it when people get mad or they're mentally ill.
Mate, you're pathetic. What's wrong with you? Do you drink and just go annoy people online?
Yeah.
What the hell is wrong with you? You're not making any sense. People are talking about...
I never make sense, bro. That's me. I'm Branch. I don't make sense.
You
I'm not supposed to make sense. I don't come here to make sense.
You come here to disrupt and do all of this. It's obvious.
We just need you to get to the crust of the argument here.
Like literally, right? The argument is this:
God damn it!
There's I love all y'all because
Is this you ending it, Branch? Because if you don't end it pretty soon, we'll go back to the other server. It's fine.
Okay.
I mean, everybody can have an invite to come over there.
Bev,
But
if that's the case, Bev, I'll just shush.
Thank you. Anybody else want to talk? Please talk before Branch just starts talking again. Otherwise, we'll just have to go. Do you want to sort out this tangent to a straight line? Science it out. I mean, I have had somebody say a tangent to a horizontal, which I thought was pretty stupid at the time. But I mean, it seems like it's what's needed, right?
Basically, the thing is how you define tangent, and you can define it in a general way and in such a way that it also makes sense in reference to a plane or a straight line, and it's no problem. It's just a different definition. Sometimes there are different definitions that are equivalent for some domain, let's say, and that are not equivalent for something outside this domain, but turn out to be useful. Anyway.
See, people even wrote it. Tangent line to a curve, tangent plane to a sphere. You know, to get it. Copy image. I'll put it back in again. Like even B-Ball did that. There you go.
Yeah, and for example, in this second example, where you have a tangent line to a curve, well, if you kind of stretch this line, extend this line a bit to the left, it would intersect the curve.
Mm-hmm.
So you have two common points.
We was talking about when B-Ball before was talking about a straight line on a sphere, right? So, and I said you can't. That's why you can't have a tangent in spherical geometry, isn't it? And you said yes, you can.
Actually, that's no problem.
You can have a tangent to a two-dimensional surface.
Yeah, why not?
Well, because the tangent plane is the two-dimensional surface.
Yeah, and the tangent to it is the same surface. It's the same plane. That's it.
It's the same plane.
Yeah.
Well, it's not a tangent then, is it?
Well, not a tangent in the sense
Isn't it more like parallel?
Of it.
Wouldn't it be more like a parallel plane?
Well, also, but yeah, I don't see a problem with calling it a tangent as well.
Parallel, right?
It has many properties in common with tangents.
You've got problems with this. Come on.
No, not really.
Well, I don't know about. I mean, you obviously you've got a tangent to a straight line. Now, what is everybody else here meant to think about that? How can they take that away? How can they look at that, what they're saying there, tangent to a sphere, and then say, no, the sphere's 2D as well as the tangent plane. So you can just have two straight lines next to each other, and we'll call that tangent. I say that's ridiculous, right? But I'm guessing you say that's flat Earth, right?
I'm not sure where you took all this from, because I kind of lost you somewhere there.
Well, you say you can have a tangent to a straight line.
Yeah, you can. No problem.
Well, I say that's ridiculous. You can't.
Okay, as you wish.
But how's anybody else here that's meant to be listening to you meant to take that away when they know a tangent, like B-Ball's done there in that thing, is a tangent to a circle or a sphere? Like it shows.
At least one person here seemed to agree with me, because they wrote that a tangent to a line is that same line a while ago.
Ooh, wow. Who was that?
Yeah, a tangent to a straight line is the line itself. I have a name now.
B-Ball? No. Wouldn't it be B-Ball?
No. The nickname is I have a name now.
Oh, a name, no. Nice. So that's another one that has two straight lines next to each other, and you call them.
But in what way next to each other? They are not next to each other.
On the same straight line, right?
Yeah, they are not next to each other. They are the same line.
So a one straight line can be tangent to itself.
Yeah, it can. It is.
It is. So you said that.
Yep.
A tangent.
Well,
to
depends.
a straight line
Basically,
is
depends.
the line itself. Wow. So that
Line.
is two
Let
of
me
you.
see how it. Tangent to a curve. Let me see how usually people define it. Oh yeah, though. So the definition I told you earlier is appears to be by Leibniz. He defined it as the line through a pair of infinitely close points on the curve. So basically, you would use the notion of a limit to have those 2 points, and then basically tending in a limit to a single point and the line. The limit of the line through these 2 points would be the tangent, and the tangent defined this way to a line is the line itself, because basically whenever you take any 2 points on a line, then the line through these 2 points will be this line, of course, according to the axioms of the Euclidean geometry. And then if you go to a limit, when you take the points closer and closer together, well, the line doesn't change. It's still through these 2 points, it's still the same line. So in the limit, it is still the same line. And this way, the tangent to a line is the same line. So that would be according to the definition by Leibniz.
Utterly ridiculous.
No, it makes a lot of sense.
It doesn't
Then
make any
basically
sense
you can...
to have a straight line being a tangent to itself.
Is Sean Hawkins joining also?
Mind you, it would support Jose. I mean, Jose was tangent, man, wasn't he? So all straight lines are tangents, so anytime he's pointing anywhere. Is that why you're saying
I
this?
don't know what you're referring to right now.
You don't know. Jose said, see that table over there? That's a tangent. See that piece of weed? He said, that's a tangent. See the squeaky globe? That's a tangent. His clock that he got from WS? That's a tangent. He had everything as a tangent. Well, if you have a straight line being at a tangent to itself, then that would support Jose. So you've got, what's that guy called? And, that dude that has a name. And you and Jose. Oh, tangents to a straight line. I mean, that'd be great. Absolutely ridiculous, but...
Basically, ask any mathematician, and I'm pretty sure that they will also agree with me.
Well... Are you a mathematician?
Not quite. By education, I'm a physicist.
A physicist? Nice.
But only by education.
Okay, so only by education?
Yep, I basically went into a career in programming instead of in physics. So, yeah, I do have some education in physics, but I'm a software developer as a job.
Okay, so what mathematics did you do? What geometry?
Lots of it. And the most, I'm not sure what adjective to use here. Let's say the most advanced branch of geometry that I had contact with was differential geometry, and it's pretty fascinating.
Okay, what about the basic geometry? The foundations?
Yeah, you can. Yeah, you kind of have to know basic geometry in order to go higher.
Okay. And does the basic tangent that you have when you start off, does that change at these higher levels, or?
Well, in differential geometry, you have a notion of a tangent space even to a manifold, and it's a bit different.
A notion?
Yeah.
Okay. But in the actual geometry, you have a tangent, right? And it can be applied in Newtonian physics, right?
In various contexts. I mean, yeah, you basically define it. Now, that's the problem. If you go into like more advanced territory, you kind of have this this idea of how a notion generalizes to various cases. So I can't say I remember what was the precise, most basic definition of a tangent line. That's why I basically am referring to various different definitions, like the one by Leibniz I mentioned before.
Right, but in physics, though, when you're doing your vectors and everything within physics, you use Euclidean geometry, and a tangent in that form would be used and applied as the straight line coming from the circle, right?
Well, depends on the context, really.
I'm talking about Newtonian physics.
Yeah, but in what basically in what precise application of Newtonian physics?
Rotational forces for bands and pulleys.
Yeah, sure. Then you have okay. I can tell you one thing. So, for example, when you have an arbitrary motion, right? You have a particle that is in motion, and it's an arbitrary motion. It doesn't have to be straight line. It doesn't have to be uniform. It can be accelerated. It can be along a curve, whatever. Okay.
But it would be defined whatever motion that is, right?
Yeah, it will be defined somehow, whatever, in some way. Basically, let's say you have a particle in motion. Then, if you want to define this particle's velocity, then the velocity at any point of this motion would be along a tangent to the path of the motion, right?
Is Sean Hawkins joining also?
Basically, for example, if you have a particle moving along a circle, then the velocity of this particle is tangent to the circle, for example, right?
Right, okay. So the circle would be the curved surface and the tangent would be a straight line. Yeah?
For example, let's say.
But the point is, that's exactly what I was talking about, Newtonian physics, right?
Okay. But my point is, if we say that it's true always, that velocity is always tangent to the path of the motion, then if we want to be able to apply this as a general rule to a motion along a straight line, then we have no choice but to accept that the tangent to a straight line is that straight line itself, because velocity will be along this straight line. And that's the point.
No, that's not.
That's the point. Then we can make a general statement that the velocity of a particle is always along a line tangent to its path. And we don't have to make a special case exception for a straight line, because then the tangent is the straight line. If you want to exclude the straight line from having a tangent, then you suddenly have to make a special case for this, because then you can't say that the velocity is always tangent to the path of motion. Because if you define the tangent this way, then when the motion is along a straight line, you don't have a tangent by your definition. So the statement doesn't apply, and you have suddenly a special case. But if you define a tangent to a straight line being that same straight line, you can make this as a general statement, then velocity is always along a tangent to the path of motion. And that's what's beautiful in math. You basically define the notions in a way that is the most general.
You just made that up.
No.
Yeah, you did. Tangent to
Not
a
really.
straight line. Fucking ridiculous. Load of bullshit. Nobody understood what you said, and I hope they didn't anyway, because it didn't make any sense.
Ask any mathematician or physicist.
Well,
I bet you that they will understand.
Are you a mathematician?
Only in the only in the sense in which I had to study mathematics in order to understand physics. So I'm not quite a mathematician, but I do know quite a bit of maths because I had to know it in order to study physics.
Well, like when I did surveying, I had to study geometry, so I knew the principles of the surveying methods that I did. That's actual geometry, right? So I learned the
some of it's just-
foundations of geometry through when I did my training. Just like you did with the mathematics when you did physics that you're now not doing anyway.
Mhm.
Right? So when you keep
Yeah,
saying,
that's cool.
go and ask a mathematician, but you're not a mathematician. Is there any mathematicians here?
Okay, then ask someone
Okay,
who
right.
will
So you're
agree
speaking
that
for
they are a
mathematicians, but then saying that we need to go and talk to mathematicians in your
Because
form
I'm
of
pretty-
your argument.
If you don't believe me, ask someone that
I
is
will,
an actual mathematician.
dude, I will, but until I do that, right, can you stop doing that?
Doing what?
Speaking for people and then asking us to go and talk to the people that you were speaking
I'm not
for.
speaking for them. I'm not speaking for them. I'm not telling you that they, I don't know. No, okay. I don't feel like I'm speaking for them. I'm basically convinced that they will agree with me. They might not. Who knows? But I'm pretty sure that they will. That's all. I'm just saying what I'm convinced about.
Yeah, you're convinced that you can call a tangent a straight line and then say it's also tangent to itself. You can do away with the curved line with a tangent and have the same straight line be tangent to itself. That's utterly ridiculous.
Yep.
Yeah.
I think so.
Yeah,
But-
absolutely, yes.
Okay, but then I tell you that ask anybody else.
It
Anybody
breaks
who
the
knows about
laws
this
of
stuff.
non-contradiction instantly. It's an instant
No, it really
fail
doesn't.
for mathematics. I can tell you that straight off.
Not quite. It's only if it's basically the same thing as saying that a square is a rectangle. I mean, a square is a special kind of a
Square
rectangle.
isn't a rectangle.
Oh, now, wow, okay.
A square's a square. That's
Yeah,
why
and
it's called a
also
square.
rectangle.
Because it's not
Yep,
a rectangle.
Okay, yeah, wow, now, okay. Because
Yeah.
I thought that this is kind of something that is repeated everywhere, that squares and rectangles are just this most generic example of A is B, but B is not A. Like, a square is always a rectangle, but a rectangle is not always a square. Maybe that's not the same in, I don't know, in your school system and stuff, but...
Okay, I'll give you one. The diagonals are perpendicular in a square.
And in a rhombus, I think it's called, right, in English?
That's not a rectangle, is it? Is a rhombus a rectangle?
Rhombus, no, but a square is.
Right, well, so
A
that's why
rectangle
a
is
square is not a rectangle. Can you not see the difference, right? A square's a square, a rectangle's a rectangle. Yes, they do all have right angles, 4 of them, yeah? But they do not have diagonals intersecting perpendicularly, do they?
Okay, let me ask you this: is what? Tell me some car brand. Whichever car brand you want. So, I don't know, a Mercedes, let's say. Is a Mercedes a car?
Is Sean Hawkins joining also?
Because obviously not all cars are have the brand logo of Mercedes on them, right? So if I define a car, yeah, all cars have like 4 wheels and stuff.
Is
And
a car a
Mercedes
boat?
also has 4 wheels.
Is a car a boat?
Obviously not, but well.
Then be
maybe there
quiet,
are
dude.
some cases.
You're making yourself look foolish. Seriously.
I'm just trying to make an example because squares are rectangles.
When you work in the framework of relativism, you can just have anything be anything you want. It's okay.
Yeah,
One
not
thing
quite what I'm
cannot be
saying.
another thing. Put that through your head. The law of non-contradiction. It's
So
simple.
a car cannot be a vehicle, right?
A car is not a boat. A dog is not a cat. A straight line
Okay.
is not a curved line.
Is a dog an animal?
These arguments are brilliant. I think we should come here a lot more often, right? Arguing about tangents being straight lines to tangents, straight lines to tangents.
To another straight line on a curve. That was B-ball. Let's not forget that one. 3 items: a tangent, a curve, and a straight line on that curve. That was extremely ingenious of B-ball.
That's how they ended up here, with tangents on tangents being tangents to tangents.
Well, B-ball wanted to have his straight line from one angle, but it's curved from another perspective, point of view being curved. He wanted that to call it the straight line, but then when he's called on it, he wants to defer to something else. It's craziness. I mean, straight line's a straight line, especially within mathematics.
Yes,
geometry.
out, dude. Yes, I did say that. But a square has perpendicular diagonals that a rectangle does not have.
No. Rectangles in general do not, but having perpendicular diagonals does not make something not a rectangle. If it has 4 right angles, if it is a quadrilateral and has 4 right angles, it's a rectangle. So a square is also a rectangle. It's a special case of a rectangle.
Yeah, I think that's what I said. Right? We're not disagreeing on that. I'm saying a square is different. Right? It has its own specificalities to it that makes it a square.
But everything that applies to rectangles in general applies to squares as well.
Yeah, but you can look at a square and go, that's a square, that's a rectangle. They are different.
You remember when we were kids and we had that little box with the shapes on it? Had a star on it, a circle, a square. If I was to give you a rectangle, would you be able to put it in the square slot?
It depends on the dimensions.
Oh my God, man! There's no way, right? There's no way to go through, right?
If you generalize everything,
like there's the shield, the Star Trek shield is up.
Well, if you generalize everything, anything can be something else. So, I mean,
it depends on how big the rectangle is. If the larger side of the rectangle.
I have the same. Okay, let's try again. I have the same size star, and I have the same size. No, let's try this again. I have the same size rectangle and the same size square, right?
What does it mean a rectangle and a square of the same size? Because
he's going to get you to define distance. Straight lines,
my God.
You'll have to do shapes and do all
You know what?
sorts of
This
stuff.
is worse than talking with Brenda.
I'm not going that deep. I'm basically mean that, well, you have squares, and when you have a square, then all sides have the same length, right? And when you have a rectangle, you have 2 pairs of different lengths. So then which one is supposed to be the same size as the square? I mean, you can't... How do you compare a size of a rectangle with the size of a square?
I thought I can go to a romper room. I thought I can go to kindergarten with pegs and squares and stars, but I don't think that's gonna work either.
No, I got a good kindergarten one. If we're gonna play a game and you define 5 rules within the game, but I changed 3 of them, can we play the same game?
Obviously not.
Oh, okay. There you go.
But I'm not really sure how that relates to the topic.
You don't see the problem with calling a great circle a straight line?
But nobody ever said that Euclidean geometry and non-Euclidean geometry are the same game. They are 2 different games, so to speak.
Okay, brilliant. Now we're getting somewhere. Brilliant. So are they the rules we're using in reality? We'll use Euclidean. You can use non-Euclidean, right? If that's what you want to do.
Well, it depends also on the application. I can sometimes use Euclidean, sometimes non-Euclidean, based on whichever better suits my problem.
Well, your non-Euclidean geometry is only 2-dimensional. It doesn't have a vertical component to it, does it?
Nope. No, you can have a non-Euclidean geometry that has an arbitrary number of dimensions. You can have a 15-dimensional non-Euclidean geometry if you so desire.
Okay, then let's have what geometry you're dealing with for reality. Go on, give us the rules that you're playing with, or do you just make them up?
Which aspect of reality?
Well, I'm talking about straight lines, right angles, how to measure angles, parallel, all of that sort of stuff. The things that everybody knows: squares, circles, spheres, cubes, all of that.
Okay, let me put it this.
That's what I'm dealing with, and that's all I'm ever coming with all the time. And also the law of non-contradiction and basic logic. That's where I'm coming from. Where are you coming from, please?
Okay, so let me put it this way. If I'm trying to describe the universe as a whole, then the best fit appears to be a 4-dimensional non-Euclidean geometry. But for some applications, Euclidean geometry, either 3-dimensional or 2-dimensional, is a good enough approximation.
Right, so what's a straight line in your geometry that you're going to use? Can you define it?
Basically, that's usually called a geodesic.
And that is?
Well, it can be defined in multiple ways.
I think
one of them
Septic said a series of infinitely small straight lines.
Well, that's kind of defining the thing by the thing, right? Because if you don't really have straight lines but only geodesics, then that doesn't really help. But you can define a geodesic as a curve of extremal length. So if you take a curve between 2 points, then
so you're saying it's a curve, whereas he said it was just a load of straight lines.
Okay, because again, we are not understanding each other because I'm using the word curve in a different meaning than you are using it. To me, a curve is basically only a function from real numbers into a manifold. So basically, what you would call a line usually.
In reality, dude.
Well, I'm talking about.
You're just talking about a series of numbers.
Not a series of numbers, a set of points. But basically, if we're talking geometry, then we're talking abstract notions, which may or may not be used to describe reality.
You should be able to define it very simply. This is reality we're talking about. Why are you struggling?
Not quite.
Well, because he's thinking in abstract. Dude, is that how you think of the world, in abstract terms and mathematical? Is that how your brain works? Is that how you solve problems mathematically?
In a way, actually.
Geometrically.
That's your problem, bro. We just found out your not a problem, but a deficiency.
Yeah, I don't think it's either a problem or a deficiency. It's actually quite helpful.
But how would that translate into reality, bro?
That's the point. You basically take a set of mathematical notions that somehow describe reality, solve the problem mathematically, and then translate the solution into reality.
That's how you bend a straight line in your brain using math.
Essie, the mathematics that I'm used to, right, is based on formulated from logic, right? And
not his though, Bev.
Well, I'm just trying to get what his mathematics is, right? So my mathematics is based on a logical formulation of truths, right, that give you a check and they check back on themselves. And it's based on logic. Is that what you're talking about with when you say mathematics?
Yeah, of course. Mathematics, set of definitions and theorems, basically. You define notions, then you derive some properties of these notions and basically define and prove theorems. That's basically mathematics, yeah. And yeah, logic is like
we start off with the definition. It's really simple. And we define a straight line. Now, in order for us to do that, define a straight line, you're going to call it a curve, right? I've heard you say that 2 or 3 times.
Yeah, it's a kind of a curve.
But it's a straight line. It's different than a curve. isn't it? It's not the same.
Yeah, that's...
It's different.
Yeah, it's kind of like with the square and rectangle thing.
Mm-hmm.
A curve is a more general notion. A
Well,
curve
actually,
is basically
it's
any
more
line,
like
let's say.
a square and a circle type thing, isn't it?
Not quite.
Yeah, it is. Like one of them has straight lines and the other one has curved lines, right? They're two completely different things.
Oh dear. But a curve is not necessarily a curved line. That's the point. A curve, as understood in geometry usually, is basically what you could also call a line, not necessarily straight. It's just some line
it's
in some
hellishly
space.
Difficult to describe the curve, isn't it?
I mean,
if you imagine you're struggling for a straight line, how would you define a curve?
I kind of already told you, but the most general definition I can come up with is, well, if you know what a manifold is, probably not, but I'll still ask.
No, go on. You're defining it. You're defining a curve, right? Presume, right, that everyone in the room hasn't got a clue. Please describe a curve. It's very simple. Go.
Yep. So that's basically what I said before, that you could say that it's just a line, any line. It's a bit more complex when you try to define it rigorously, but you can think of it just as any line. Can also be a straight line. And the rigorous definition would basically be a continuous function from real numbers into the manifold. So when you have some manifold, which is a set of points, then you have some function that assigns points to real numbers, and if such a function is continuous, which basically requires the manifold to have some topology, then that's a curve.
And you defined a curve as a straight line, and I think earlier had
no, not as a straight line. A straight line is a special case.
You said it can be a straight line.
Yep,
I don't know whether you noticed you slipped that in there, but you definitely did. As you were defining a curve, you slipped in, it can also be a straight line.
Yep. So what I meant is that a straight line is also a special case of a curve, but curves are more general.
That's what I was just going to get to. I asked you to define a curve, and you said it was a straight line. And then I was going to ask you to define a straight line, and would you put that in the curve bracket as well?
I would say that a straight line is a special kind of a curve.
Yeah.
Basically a curve with some additional properties.
So you can have a curve being a straight line and a straight line being a curve. And you don't see that there's a problem with the law of non-contradiction there at all, do you?
It's not a law of it's not a contradiction. There is not a problem with law of non-contradiction because you're still stuck with definitions that basically, well, you're still trying to stick your understanding of the word curve to what I'm saying that I define as the word curve. Well, the other way around. What I define the word curve to mean.
How would you do anything in reality with anybody? The way you're describing things in general terms. It's like me having a whole truckload of tools and half of them will measure something. And I just say, hand me the measuring tape. And somebody could just hand me anything as long as it had some arbitrary numbers on it. Well, I mean, it'll measure because it's got some arbitrary numbers. So just, here it is. It's like, no, I needed the measuring tape, but you hand me a square.
Yeah, he pass you a hammer. And then you go like, well, measure it in hammers. God, can you not measure it in hammers? I mean, that's ridiculous.
Yeah, I don't think we're understanding each other, but yeah.
Because you haven't got a clue. You've got a curve being a straight line and a straight line being a curve. How do you differentiate between the two if they're both the same and they can be each other?
I didn't say they are both the same.
Yes, you did.
The fact, no, that again, if a dog is an animal, if I say that an animal can be a dog, it doesn't mean that a dog and an animal are the same thing.
This guy's way gone, man. It's a complete waste of time.
Yeah.
still different words with different meanings, but I still can say that an animal can be a dog and that a dog is an animal.
Such a sophist. I don't know how anyone would bother even talking to you. And like science, if you're struggling with this basic concepts of geometry and mathematics, then
I
wouldn't
not
even
me who is
attempt
struggling
to talk to science with you. You're
it's
far
not
out,
me who
man.
is struggling here.
Science is definitely out with you.
Yeah.
If you say so.
Absolutely.
Dude, you don't know what a straight line is. You're fighting a straight line and a curved line. You haven't even gotten past step 2.
I'm trying to tell you that there is some more general meaning to these words than what you are used to, but you kind of are not really interested in it, which is, well, I guess you're allowed
That's sophistry. You're just making, bro, you're making stuff up, bro. For real.
Not really.
It's sophistry,
Not
yeah.
really.
Yeah, your cog this is not allowing you to see that you're holding 2 thoughts in your mind at the same time, 2 opposing thoughts.
Yeah.
That's cog this, bro.
Find a textbook for differential geometry and see for yourself. That's all I can tell you. It's not what I made up. It's basically a
It's
very
something
nice
you
branch
read
of
and
mathematics.
believed, yeah. It's something you read and believed. I bet you're highly educated, aren't you?
I don't really have to believe that. I understood it. There's a difference.
You're highly educated, aren't you?
Define highly educated. I'm
University level. University level.
Yep.
Yeah, I can tell. I can tell. Yeah, I can tell.
I'll take that as a compliment.
Well, it can be taken as a compliment if you've taken what you've learned and applied your own brain into it, but you haven't. You just went book deep, like whatever you read, you believe. I get it. I understand.
Yeah, that doesn't sound like you understand because it's not a matter of belief. It's a matter of understanding.
How can you understand that a straight line curves? How can you understand that? Something must be wrong there.
Well, I never said that a straight line curves. That's one of the problems here.
You never said that a straight line curves?
Yep. I said that a straight line is a kind of a curve, but it doesn't mean that it curves. You're kind of assigning a colloquial meaning to these words, and they mean a slightly different thing in the context of mathematics.
Oh boy, I don't know what to say to that, bro. I mean, if you can't differentiate between a straight line and a curved line, I mean, there's nothing else we can tell you. You agree to the law. Sorry, go ahead.
If this is what you basically understood from what I was saying, then I can say the same thing. I don't know what more to tell you, really.
Okay, hold on. You agreed to the law of non-contradiction, correct?
Yep, sure.
So you don't see the irony and that you don't understand the difference between a straight line and a curved line, and you think they can be the same, and you can choose between them interchangeably?
I don't think you understood what I was trying to say, but that's okay. Because that's not at all what I said, but yeah, I'm kind of a bit tired of trying to explain again.
You're the second person today that told me that's not what he said.
Yeah, well, that may be so. Looks like there's a pattern there, right?
Yeah. Well, look, at least you're honest and you're not rude, and so I can't have anything against you. So, look, if that's what you believe, that's what you believe, bro.
Okay, yeah, we can always agree to disagree if that's what you want, I guess. I mean, I'm not on a crusade to convince everyone and etc. etc. I can just talk about these things and you what and how I understand, and that's basically it. What you do with it is your thing.
No, but you're not getting one thing. That's not what you understand. That's not you talking. That's your schooling talking. That's what you learned. You're not applying your own brain to this, bro. That's the problem.
That's what you think, but I'll have to disagree on that.
Who's told you to come and educate us with this? I mean, how many of the other Globers have you already educated with this stuff?
Why do you assume that I educated anyone? I mean, if
Well, I mean,
somebody is interested in this stuff,
you were trying to educate us. You just said that. So, how many of the Globers have you tried to educate?
No, I kind of told the exact opposite thing to what you're saying. I said that I'm not on a
you tell them the opposite that you're
anyone.
telling us. Is that why you're telling us that tangents are to straight lines?
What? No, seriously, what?
You said the opposite. You tell them the opposite than what you tell us.
No.
Oh no! So that
would
would make sense, right? That you're telling us just
Jesus
like everything
Christ.
upside down,
No.
as though you're treating us like.
No, what I said is that you're basically twisting my words to say the exact opposite to what I said. I said that I'm not trying to convince anyone of anything or to educate anyone. I'm just sharing what I understand, and that's all. What you do with it is your thing. It's your decision. That's it. I can't educate you if you don't want me to, really.
So there you go.
It's
Like
that
you
simple.
said, you're trying to educate us.
I'm not trying.
You
I'm
did.
not
You
even
just
trying
said
because
you
I know you
can't
don't want to.
educate us. Why do you
Yeah, if
assume you can't educate us?
If I say I can't fly, it doesn't mean that I'm trying to fly. It just says that I know I can't.
How do you know you can't?
Because I know you don't want to be educated.
What do you mean? You do? Of course I want to be educated. That's what we're here for. We're here to learn. All of us are.
Your actions kind of say something different.
No, I'm learning. Dude, constantly learning. This is all an educational experience for us. So what is it that you assume you can't educate us with? Right?
Okay, then maybe I am wrong. Well, people can be wrong sometimes. Me too.
So, like I say, how many of these conversations that you're having with us have you had with the Globers?
Not too many, to be honest. Because I'm not often on voice chats and etc.
Okay, so you've never had the conversation about tangents being tangent to themselves?
No, actually, no.
No. So were you trying that out with us, or do you not think you'd have been better off, checking it over with somebody else first?
It's not trying out. Basically, the topic arose, so I said what I know about the topic. That's it.
Okay. And that would that be the sort of thing that you would like to educate us about?
But why are you assuming that I would like to educate you about anything?
Because you said that you wanted to.
No, I didn't say I wanted to.
Okay. But, I mean, is that the sort of thing you would like to tell people? Because my lad just came in. I told him about it, and he went, nope. So, I mean, he wouldn't really have it, any of that sort of stuff that you were just saying. Straight lines being curves and curves being straight lines. And...
Yeah, not quite what I said, but okay, yeah.
Well, he'd be able to hear it back. So you've got that, and also the tangents being tangents to tangents and not needing a curve. He definitely went. He went nope.
That actually is what I said. Yeah.
I know. Yeah.
And I'm standing by it.
Well, yeah. Yeah, that's why I was asking you if you'd ever tried it on anybody else, because my lad went nah, and me definitely nah, that's stupid.
Okay. Okay, sure.
Did you major in arts or something in university? If you don't mind me asking.
Nope, only physics.
Physics? Seriously?
Yeah. Seriously.
Not astrophysics, but actual physics.
Yep, just physics.
Wow.
With a specialty in general relativity.
General relativity, no doubt. Wow.
How long ago was it that that you came out, and how many years were you in higher education?
That sounds a little as if you were asking about time in jail or something.
Well, no, it was like how, because I mean I'm quite old now. My time in that sort of thing was quite a bit ago, and I obviously did practical stuff. Probably different, but my lad's going to be going in. He's going to be going into this schooling system.
Yeah, I guess in this environment I'm relatively young. I finished my studies 9 years ago, so I'm just over 30.
Yeah. 20-year change-ish, something like that. And how long were you in the actual, call it academia, right? Out of schooling and into college, university, or whatever?
Yeah, I'm not sure if the system works the same way as it works in the UK, for example. But basically, well, the whole education lasts for like 17 years if you count from elementary school to the end of university. So it was the final 5 years was university, if that's what you're asking.
Yeah. That's from out of the schooling system.
Yeah.
Me personally, when I left school, I went into a trade. I did my carpentry and joinery craft certificate, 2 years, and doing my trade. And then I did the extra year for the advanced craft certificate. And then went into a 2-year building construction course. And then decided I wanted to do teaching. So I guess I did about 6 years of after schooling. But most of that's practical sort of stuff for me.
Okay.
So similar sort of, timing involved. But there wasn't an awful lot that was theoretical. Most of it, what we did was practical.
I see.
Applied. When you did your physics, how much was that was applied and theoretical?
There were some courses in experimental physics, so we had to do some experiments like plan and execute and stuff like that. Not that much, probably less than you would expect, although I kind of went into the theoretical physics path, so I had less of it than maybe some other people in the university as well.
Right. So what?
But yeah,
as a
some of
percentage,
that.
50%?
Oh dear, no, that definitely less than 50%.
Less.
No, it was like a one course out of let's say, I don't know, 8 or so per year, something like that. But that's very approximate.
About 20% then.
Oh,
generous.
Might be even a bit less, but yeah.
15. That's not a lot, that. So the rest of it was theoretical.
Mostly, yeah.
Were you in like theoretical down on the ground, or theoretical, up in space type stuff? Where did they have you working?
Actually, kind of both, let's say. Although actually, if you study physics, it's like the more.
Or like
you study
particle.
more of the
Like, you know, little
Yeah,
tiny
particle
stuff.
physics was a
Yeah.
yeah, particle physics was a part of it. As I said, also general relativity, which is kind of the opposite side, like huge stuff and space and stuff like this, right? But yeah, basically all kinds of things. You learn the whole spectrum, and then you basically choose a specialty and you go deeper into that.
Cool. Well, when you say learn, if none of it's actual practical, like you just are you theorizing on theories, right? Or are you just learning other theories? Are you allowed to freeform your own theories, or are you just sort of, or are you theorizing on stuff that other people have actually done?
Not quite either of these. I mean, it's not that you're not allowed to have theories. Of course, you can have theories if you want. It's not like somebody tells you what to think, but you're basically learning what, well, you're basically learning what the humanity has learned up until now, right? So the theories that have been tested and how they have been tested and how basically the models that are being used in actual science work right now. So you're mostly learning about that, but of course it's well, it's not like you're memorizing stuff. You have to actually understand where this came from and how this works internally. So it's almost as if you're discovering this all from the start. It's like it's a bit as if the professors were kind of guiding you through the whole path of discovery that the humanity went through, because it's also partially chronological, but not quite. It's some things are a bit switched in the sequence because it sometimes makes more sense like that. But yeah, when you're learning that, it's almost it's almost like guided discovery. You're basically learning how to derive stuff and how to actually come to the conclusions.
Could I read 3 statements and see if you agree with them?
Okay.
All right. We're going to do the 1, 2, 3. Mostly just the 2 and 3s that we care about. But the number 1 is pressure is proportional to the depth and density of a fluid. The shape of the container or object has no effect on pressure.
Yeah, pretty much.
All right. 2, connected liquid in hydrostatic equilibrium rises to the same height in all open regions of the container.
That sounds correct.
All right, now this is the last one, number 3. The pressure is the same at all points on a horizontal line through a connected liquid in hydrostatic equilibrium.
With that, I will almost agree, because this makes a shortcut that is usually not important, but is quite important when discussing things with in the context of flat Earth and stuff like that. Because yeah, this kind of equated level and horizontal there. And while that is usually a good approximation, when we're talking about this and we want to be precise, then what we would say is that the pressure is always at the same level, but not exactly on the horizontal line, because as
what's the distance that wouldn't hold true, that third statement?
Well, technically any distance, but on small distances you just won't notice the difference.
Technically any distance?
Yep. Technically yes, because, well, obviously, and I think that's a point you guys are raising quite often. Well, a plane is not a surface of the sphere, right? Those two are different. So then if we say that level is the surface of the sphere, then obviously if you have at any distance 2 points that are on the same level, on the same surface of the sphere, then they are not on the same horizontal plane. So in this sense, this is different at any distance, but then, well, then there is the problem of the scale, right? If the distance is like 1 meter, then the difference comes out to be, and now let me quickly calculate, approximately well, 8 centimeters divided by 1,000,000, so that's not much. That's what, 80 millimeters, so 80 nanometers that would be, so that's not much. Try to see the discrepancy by 80 nanometers at the distance of 1 meter.
80.
That's
how many
80.
zeros is that then? 0 point.
I think, wait, not so that I think 7 zeros and then 8, something like that, meters.
And that's over what? A meter, did you say?
Well, it was interesting. We had the discussion with the guy about it, and if I told you I had a tool that could measure within a 50 millionth of an inch, how far would that be accurate to?
How much? 50 or 15 million?
50.
50. Yeah, 50 million.
50.
Okay. Let me do the math quickly. Although that. Okay. So assuming, but now again, that's assuming that you can precisely, basically establish the horizontal plane over this 1 meter, and now you would have to do it with the precision that is greater than this 50 millionths of an inch, which is another challenge in itself. But assuming you would be able to do it with such a precision, then wait, 50 million. Okay, I'll do it in metric because that is easier for me.
Yeah, that's fine. The last guy that did it, he did it in metric too. Yeah.
Okay. So wait. Now, if I didn't make any mistakes, this came out to be about 4 meters, or if you want imperial, that would be something along the lines of like 14 feet, 13, 14 feet, something like that. But that, again,
that you could be accurate to 50 millionth of an inch with a.
Yeah, but again, that's assuming that you are able to do every other element of the measurement exactly, precisely, with no uncertainty, which is kind of a very, very far-fetched assumption. So you would have to include all the other uncertainties, like the uncertainty of establishing a horizontal plane, like with what precision you are able to do that, and then how
communicating vessels with a micrometer, 50 millionth of an inch. How far could I go to get that accuracy, making a horizontal?
But the problem, yeah. Wait, so again, what are you asking? How far you can put the communicating vessel so that it's still horizontal, something like that?
Yeah.
Yeah, so that would be about this number that I told you, like 4 meters or something like that. So about 14 feet.
Okay, fair enough.
Wow. Well, so how far at 200 feet? Well, like, what would the... oh, wait a minute, 200 feet, that's a bit bad, isn't it? Say 100 meters.
Okay.
Is it 100 meters? Is that about too far, that? No, that's about right, isn't it?
Well, 100 meters, isn't it like 300 and some odd feet?
Yeah, 330, something like that in feet.
Oh,
yeah.
nice.
Yeah, that'll do then. What at that sort of distance? Keep it metric, 100 meters.
Okay, so basically what would be the difference between horizontal and the sphere at that distance?
Yeah.
Is that a question? Okay.
Yeah. And would that be the drop from horizontal, right?
Yeah, so that comes out to about 0.08 centimeters, so slightly less than a millimeter.
Over 100 meters?
Yeah.
Are you sure?
I would have to double check.
Yeah, I suppose.
But approximately, yeah, that should be about right. Because there's this common approximation of 8 inches per mile squared, right? It translates almost exactly into metric as 8 centimeters per kilometer squared. So that's not an exact formula, but it's a good approximation. So I'm currently using this approximation. I could calculate it more precisely, but I think that should be enough for now.
8 centimeters on a kilometer. Let's have a look at that. See how that matches the Ruhif numbers. Yeah, see it does it. It's pretty much relatable, right? But I mean, as you'd expect, over 100 meters, it's 0.78.
Yeah, so I
over
was saying
1,000, it's
0.8, but yeah. Yep. Yeah, that sounds about right.
How do you work that quadratic function into it? Mentally, like?
What do you mean?
Well,
so I'm basically...
from, let's say from 100 meters, from 0 to 100 meters, it drops 0.78, right? And then over the next, from 100 to 200 meters, well, over the total distance from 200 meters, it's 3.13. But obviously, from the first 100 meters, it's 0.78. So then from 100 to 200, the drop increases, right? It's nearly like 2.
Not quite, yeah. I see what you mean.
Or something like that. And then over the next one, the next 100 meters, you've got...
I see what you mean, but yeah.
Nearly 4.
Yeah, and that makes... Yeah, because the problem is you're kind of... if you want to take the drop from 100 to 200, well, if you were measuring it from the 100 mark to 200, you would also get this 0.78 millimeters, but you would be measuring it relative to a different horizontal plane. And since this horizontal plane would be tilted relative to the horizontal plane established at 0, this tilt would add those, I don't know, 2.4 no, not 2.4, but about 1.6 millimeters that you find the discrepancy.
Yeah, intersecting horizontals, right?
Yep.
Yeah, I've never heard of that.
Yeah, that's how it works on a sphere, basically.
It's not how it works in reality, though, because remember, I did that.
Actually, it does, but I know that we don't agree about that.
Yeah, that's why, when I came round here, it was a little bit weird for me, because obviously I'd trained and done that, and nobody had ever mentioned it until I came into a Discord server. And I was told by people, how much surveying have you done?
Are you asking me?
Yeah.
Not much. Basically, my whole experience with surveying is renting a theodolite and doing some measurements just for myself. Well, for myself and for the video I put up. I probably linked it at some point, but yeah. I'm definitely not a surveyor, if that's what you're asking.
Yeah. Like I say, I've never heard of intersecting horizontals.
Yeah, because in most applications it's not important. It's so...
Well, it was surveying that I did. Land surveying.
Yeah, at what distances?
The distances that we did. Yeah.
So what distances did you do? What order of magnitude?
Did we survey?
Yep.
Well, like, you mean total distance?
Yeah, for example, what was the largest distance that you were, I don't know, for a single measurement, let's say.
No, not single measurements. I mean, you mean like total distance that we had to survey the land?
No, not necessarily, because it's not that important if you
That's what we were doing. Measuring
okay,
points
but the
and adjusting elevations. Yeah.
Yeah, okay, yeah. I kind of don't deny that, but the point is this kind of this thing that the horizontals kind of tilt and get more and more, and intersect and stuff like that. It doesn't really get important in multiple measurements. It would be quite important in a single measurement of over a large distance.
No, yeah, I'm just saying.
Quite,
I'd never heard of it, right? It never even came into contemplation that horizontals intersected, right? Because I know the parallel. All horizontals are parallel to the plane of the horizon. Right?
Horizontal to what?
Oh, it's Branch again. Bloody hell, Branch.
I'm just saying, like,
you're trying to
when you
shut
say
it
the
down.
word horizontal,
They're horizontal to the plane of the horizon. They're parallel.
Whoa.
It's weird, isn't it?
Shut up, bro. Please, shut up.
Yeah, it's a good approximation over small distances.
Parallel. It's not a very good approximation. It's an exactness defined in mathematics.
That's where you and I disagree, but let's not go into that right now, especially since I will have to go to sleep.
I mean, there's also
Sounds
another
like Branch
interesting,
is
there's an interesting way of thinking about it too, right? Like so. Let's say we talk about two horizontal lines, right, or parallel lines.
Horizontal or parallel?
They can be horizontal and parallel, bro.
I know they can. Yeah.
Okay, so let's talk about two horizontal parallel lines.
Yeah.
And
do you want to name them?
If it's on the globe, and they're moving to the contour of the globe, yeah, they'll meet at the pole. If they're moving,
did you say parallel horizontals?
If they're not moving to the contour of the globe, and they're literally just going on the tangent from the globe straight out to wherever the fuck, then those 2 points necessarily won't meet. But there is this entire thing that a lot of scientists are not sure about, and that is that the entire fucking universe actually has a shape.
Right,
therefore,
okay.
The
Branch,
universe has a shape.
Branch, you've definitely had some more drinks, and have you got kicked out of other places?
I'm just saying, bro, if the universe has a shape,
yeah,
then those lines would meet because of the curvature.
Right,
of the
well, I
universe.
think Science It Out wants to get going as well, and we've had a good time, and this is gonna wreck it, Branch. So
Hey, motherfucker.
I don't want to ruin it.
I ain't talking shit though. Just Google fucking.
No, I'm not talking to you, Branch. I'm talking to Science It Out. Like we'll have to do this again some other time, man. It's been good.
Sure. Yeah, nice chatting to you.
Yeah. Bev, why you gotta fuck off, bro?
Yeah.
I was just letting Science It Out go so so it doesn't turn into awkwardness before we say goodbye.
Yeah, but Branch actually wasn't wrong. There is this question of the shape of the universe and whether it has curvature or not, things like that. So yeah, that was.
We're not bothered about fantasy out what you want to do. But Branch is going to tell us now. Anyway. All right, cheers.
Yeah, bro, it's called the Axis of fucking Evil, bro. Yeah. Weird name, but just look it up.
What, the Axis of Evil is the shape?
But yeah, actually the chat was pretty nice, so yeah, thanks for the conversation, and yeah, maybe see you again.
Sweet.
I'm not too often in voice chats, but I'll probably pop in at some point.
Hey Bev, Bev.
Oh yeah. Yeah.
Well, if you're leaving simply because I was talking out of line, You do know that I can chill.
Well, no, I didn't say I was leaving, although I might do.
Okay, but if you want the mic without me, I don't mind.
No, it's all right. It's getting late, and actually, we should be watching UFC.
Are we gonna?
I haven't chilled in your room for a long time, Bev. I kind of miss it. I'll be back in a sec, like one day, pretty soon.
Later.
If you enjoyed the content, please support On the Level and future projects. Membership subscriptions available now, or come and get involved at Next Level Discord server. Thank you.